Hello, Tom from Every Step Calculus, everystepphysics.com. This is a Calculus 3 problem, XYZ, and it's finding the work done by a force over the curve in the direction of increasing t. Total nonsense, okay? Integrals they find areas under the curves. There's no integral in the world that can ever find an area over the curve. The reason is because all of calculus needs an axis. And in this case with t, it's the t is the x-axis, okay, along the horizontal line here, okay? And if you're going to go over a curve, there's no limit to how high you can go, or so it won't work, okay? So keep that in mind. But anyways, we're going to do this problem here so you can pass a test and get out of calculus, never to touch it again, okay? So index 8 to get to my menu. I'm already at work done, now the f of x, y, z, so if you see that, you're going to go to, I'll show it to you without, here's work done, x, y, z, okay? So you choose that in my menu. Now there's 136 items in this menu, okay, as it goes up and down, okay? So you hold the second button down, your second key, and use the up or down cloverleaf here to go through the menu quickly, okay? Otherwise it goes one by one like this, okay? So we're going to go up here. That's just a trick, I'm just telling you quickly here about using my menus. So we're going to go up and choose that. I'm pressing enter now, okay? And we're choosing I, J, and K. You see I, J, and K here, right? If you made a mistake in X, Y, Z, it would figure it too, but generally I try to keep everything systematic. So we're choosing the number beforehand or the scroll to it. I clicked on number 2, and here's the force field. Here's the formula, force, and dr is the RT formula system. So work is equal to the range a and b, the integral f, I, j, and k. Here's I, j, and k and t's, and then you take the derivatives of those. I'll show you how to do that in a second here. And with respect to t, so the integral is with respect to t, and we're taking these two vectors here, the force I, j, and k, and the r prime, which is the derivative I, j, and k, and multiplying it together, dot product. That would mean you multiply the first times the first, second times the second, third times the third, okay? So we're going to enter and you press alpha first to enter minus 6y, okay? So I'm going to show you that I've already entered these in the simulator because sometimes this messes up when you put it in there, but I've done it quickly. But I pressed alpha and did it just like I said, minus sign. And there's an operator minus, which you got to use in front of the 6 on the calculator, and then there's an actual minus sign that you use at other, like for instance here would be a minus sign if you used it, and here would be an operator sign, which is the one at the bottom of the calculator, okay? So don't mix that up. And you can see that I've entered them all correct. Here's the vector x, y, and z, okay, just like here. I always give you a chance to change it in case you made a mistake, so I say it's okay. I've already entered the I, J, and K. That's the R. This is the R T formula. So here's RT, and his R of I, J, K is cosine T, sine of T, and then 0 for the Z part. K is Z. Say it's okay. Now we do the derivative. Derivative of cosine of t is minus sine of t. Derivative of sine of t is cosine of t, and then derivative of 0 is 0, of course. So we find that first. We replace the f of x, y, z with the r of I, j, and k. Okay, I'm going to show you how to do that. That turns out to be minus 6 sine of t, right? This is the y. We replace the y here, so it become a minus 6 sine of t. Here's the x. Replace the x here with this, 6 times cosine of t, and 0 for z, which makes it 0. Okay, so we've done that. Here's the formula again. F of ij and k times the r prime of ij and k dt. Okay, we're going to enter the range. I've already done that, 0 to 7. Save time. Here's 0 to 7 for t. I say that's okay. And we get the integral from over the range of 0. This is a definite integral now. 0 to 7. We got the two vectors here. And we're going to multiply that together with dot product. Multiplying them together. Here they are. We haven't multiplied them yet. But now we have, and this is the way they turn out. Now, who could do that? Are you going to multiply those together in a test and come up with this? Huh? I don't think so. Okay? That's why I programmed this crap. Okay? Now, those added together then turns out to be just 6. Okay? Now, good luck in computing that. Now, any of us could do that if you studied it for a week, that particular problem, but you got tons of problems in a test, and you got other classes you got to study for and stuff like that. So why study this stuff? So over the range of 0 to 7, okay, we're going to integrate, which we add t, okay. At t equals 7, work equals 42. At t equals 0, work equals 0. Upper minus lower, always in calculus and physics, okay. So work is equal to 42. That's the answer. Now notice they don't have joules on here. And any problems like that in calculus, they don't have joules. You don't know what, I mean, what does this all mean? So you got the work done of 42 joules. I mean, who wants that? And whether it's true or not, who knows? I mean, it's just baloney, you know, as far as I'm concerned, after 25 years of doing this stuff almost every day. I say all calculus is baloney. It's just like studying Sudoku or crossword puzzles, or you know, studying Latin language or something like that. Completely worthless. Hey, buy my program. They're only $40. You get 460 programs for $40, and you know, it'll certainly help you, and you don't have to. I've done all that studying for you. You don't have to study this stuff much. You have to know about derivatives and integrals, how to do those quickly, and know something about calculus to pass any test. But then this is certainly going to help you to pass or get a better grade. Okay. So buy my program and enjoy passing calculus. Hey, have a good one.